Hi, this is the second video in the probability series. In this video, we're going to look at Venn diagrams. So whether it's a 2-Venn diagram or 3-Venn diagram, you will get at A-level some weird and wonderful looking Venn diagram questions. So you need to have a good understanding of what each section in the Venn diagram is representing. So a Venn diagram is basically circles that are used, and each circle is used to represent one event. So here's just a little tiny example. In a class of 32 students, 26 like apples, 18 like bananas, and 14 like both. Okay, so hopefully you notice that these don't add up to 32. They won't add up to 32 because it's taking into account overlap. So what we do is, if we want to show this information on a Venn diagram, we draw two circles that are overlapping. Like that. So each circle is going to represent one of the events. So A is the event that they like apples, and B is the event that they like bananas. And then we put a rectangle around the Venn diagram so that the whole thing is the sample space. The whole thing will show all possible outcomes, including those that don't like either apples or bananas. Now, when you're filling in a Venn diagram, you always start in the centre, in the overlap, and then you work outwards. So first of all, I'm going to put in the 14. 14 like both apples and bananas. That's the overlap. The whole of that circle, including that 14, are the students that like apples. So if 26 like apples altogether, there's the first 14 of them. That means there must be 12 there. And this moon here is representing those that just like apples. This circle is representing all those that like bananas. 14 of them are there, which means there must be 4 there. So you're starting at the centre, and as you move out, you're taking away. If those together add up to 30, if there are 32 students, that means there must be 2 that don't like either, and I tend to just put that in one of the corners. So this is now listing the whole sample space, all the different possible outcomes are there. Okay, if a student is chosen at random, what is the probability that they like apples but not bananas? So there are 12 that like apples, so the probability that they like apples, actually I won't write it, otherwise I have to write a big sentence. Probability will be 12 32s. Okay? They like bananas but not apples. Bananas but not apples, that's just going to be 4 32ths. And they don't like either, well that's 2 32ths. Okay, now notice in this Venn diagram I have put what we call the frequencies, so the number. What we could also have done is put the probabilities in there. Works in exactly the same way. So sometimes if you're given a list like this where you've got frequencies, put the frequencies in. Other times they might just give you some probabilities. You have to write the probabilities in, whether it's in fraction form or decimal form. So it doesn't matter whether you do frequencies or probabilities. Okay, parts of the sample space that are important to know. This bit here, that is called the intersect. So that is the probability that A occurs and B occurs at the same time. And we can write that with probability theory notation with a little funny n. That's an intersect sign. So probability that A intersects B means the probability that both A and B occur at the same time. This whole thing here is called the union, and that is the probability that A occurs, or B occurs, or they both occur. So this is the bit that some people usually forget. So it's A occurs, or B occurs, or they both occur. And we can write that as A union B. All of this shaded area, well, it's everything outside of A, so the shaded area is showing everywhere that A is not happening. So the probability of not A, which I've already said, we can write like that. Okay, in the next video, we're going to be looking at using this notation in more detail with more complicated versions that you need to be able to recognise. Okay, I'm going to do a few basic examples and then we're going to look at a couple of problem solving examples that require algebra. So in a class of 30 students, 7 are in the choir, 5 in the school band and 2 students are in the choir and the band. A student is chosen at random from the class. Draw a Venn diagram to represent this information. So choir, band, 2 students are in the choir and the band. So because I've just given frequencies, I'm just going to use frequencies in my Venn diagram. So 2 are in the choir and the band, 7 altogether in the choir. So that must mean that's 5, so the whole thing adds up to 7. 5 are in the band, which means that must be 3. If there's 30 students altogether, that means there are 20 that aren't in either the band or the choir. Okay, B, find the probability that the student is not in the band. Well, the students that aren't in the band are these 5, because they're just in the choir, and these 20. So that's 25. I said 25, but my hand did a 3. 25 30ths. Okay? Or you could say it's 1 minus that. The student is not in the choir nor the band, so that's going to be these numbers here, these students here, 20 out of 30. Okay? That's 5/6, that's 2/3. Here's an example of a triple one. Okay, quite a common looking one. You can get more complicated ones. You might get 2 that are overlapping and 1 that's not overlapping any. You might get 3 that are all in a row. You might get 1 that's inside the other one. So they can get a bit complicated, but this is a standard looking one. In a class of 20 students, 3 have visited France, Italy and the Netherlands, 7 have visited France and Netherlands, 5 have visited Italy and the Netherlands, and then we've got loads of information. Okay, this here is the overlap. So this is going to be the central bit. So here is the bit that's overlapping France, Italy and the Netherlands. So this is our 3. 7 have visited France and the Netherlands, so France and the Netherlands is this overlap here. So including that 3, that must be a 4 there to make up to 7. 5 have visited Italy and the Netherlands, so that has got to add up to 5. 4 have visited France and Italy, that's got to add up to 4, so that must be a 1. 8 have visited Italy, so all of this has to add up to 8, so that must be 2. 12 have visited the Netherlands, all of that has got to add up to 12, so that must be 3. And 10 have visited France, all of that's got to add up to 10, which means that must be 2. And then all of these have got to add up to 20, which means that must be 3. How many students have visited none of the 3 countries? 3. How many have visited France but not the Netherlands? So these have visited France, these have visited the Netherlands. So the ones that have visited France but not the Netherlands are these 3 here. So including the 1, no mention of Italy. So it's 3. How many visited France or the Netherlands but not Italy? So France, Netherlands, but not Italy. So it's France or the Netherlands. So 2, 4 and 3. These ones have all visited Italy, so we can't include them. So it's these 9. Okay, those are all frequency questions. These are now asking probabilities. A student is selected at random. What is the probability that they have visited just one country? So what's the probability that they visited just one country? Just those ones there, the ones without the overlaps. So that's 7/20. What's the probability that they visited 2 countries, just 2 countries? So 1, 5, 7. Again, so 7/20. Have not visited France. So everything outside of that. 2, 2, 3, 3. So that's 10/20. Don't forget the ones here. This is a common mistake, is to forget these here, which is a half. And then have not visited France or Italy. Haven't visited France or Italy. So it's these 3 that have just been to the Netherlands and these 3 who haven't been anywhere. So that's 6/20. Okay, so that's a triple one. Okay, so just be careful when you're filling it in. Start with the centre, then work out, then work out. And then the last one, this one, we're using probabilities inside the Venn diagram. So the probability that Bob has coffee in the morning is 0.8, the probability that he has toast is 0.3, and the probability that he has both is 0.24. Show this on a Venn diagram. So we've got coffee, we've got toast. The probability that he has toast both is 0.24. So we're putting probabilities in the Venn diagram this time. So coffee is 0.8, so the whole thing's got to add up to 0.8, which means that must be 0.56. Toast is 0.3, which means that must be 0.06. So if you add all of those up, that all adds up to 0.86, which means that must be 0.14. So what is the probability that Bob has nothing? 0.14. What is the probability that Bob has toast but not coffee? That's just this moon shape here, which is 0.06. Okay, so that's just some basic examples of how to fill in and read off the Venn diagram. Just going to look at a couple of problems. Problem solving. so this is usually, you usually need some sort of algebraic approach for these ones. So given the probability of A is 0.7 and the probability of B is 0.4, and neither A or B occur, is 0.15, find the probability of A but not B. So a Venn diagram has been drawn. We know that all of that is 0.7. We know all of that is 0.4. And we know that neither A or B occur. That's outside here. Here is 0.15. So we know this. We know all of this. And we know all of this. What we don't know is how this is distributed. Okay, now the key for a Venn diagram is that you need to know the centre. Once you know the centre, you can go from there. Okay, at the moment we don't know what this intersect is. So like any good mathematician, if we have an unknown, then we use some algebra. So I'm going to put x in there to represent my unknown probability for my intersect. That means that I can write an expression for this moon. Well, if the whole thing is 0.7, then that must be 0.7 minus x. And if this whole thing is 0.4, that must be 0.4 minus x. Now we've got one unknown, so we need to form one equation. So we need to think about, what do we know about this? Well, we know that all of this together must equal 0.85 because this is the union. Okay, so we can use that to form an equation. 0.7 minus x plus 0.4 minus x must equal 0.85. So if we could solve that, that's 1.1 minus x plus x cancels, so we've got 1.1 minus x equals 0.85. So x must be 0.25. Now just be careful, that doesn't answer the question. Find the probability that A occurs but not B occurs. Okay, so a common mistake would be to forget what you're doing and think that's the answer. Okay, so always go back to your question and make sure you've actually answered the question. If x is 0.25, the probability that A occurs but not B occurs is here, in this moon here. So the probability that A occurs but not B is going to be 0.7 minus the 0.25, which is 0.45. So that's the actual answer to the question. Okay, so if you need to draw a Venn diagram and you don't know what the intercept is, then you can call it X or something, a letter, and form an equation in order to work it out. Okay, now what I would like you to do is pause the video and have a go at this. You can use the information given to form equations. Now you've got 3 unknowns, so you're going to need 3 equations to be able to solve. So pause the video now and have a go. Okay, so this is what you should have done. Probability of C is 0.5. So if this is 0.5, then the first equation we can write down is y plus z equals 0.5. That's equation 1. We're told the probability of B is 0.4. So we can say that x plus y plus 0.12 equals 0.4, which means that x plus y must be 0.28. That's equation 2. Okay, now that's exhausted the information that you've been given. However, you do know something else. These three, all of this is the union of all three events, and that must equal 0.91 because the number outside of that is 0.09. So we know that 0.24 plus x plus 0.12 plus y plus z equals 0.91. So that's using the union. Okay, so if we shuffle these two bits to the other side, x plus y plus z will equal 0.55. That's equation 3. So we've got 3 equations and we've got 3 unknowns. Okay. Now the easiest way to do it here is you could put that there. So we know that y plus z is 0.5. So if I say x plus 0.5 equals 0.55, then x will be 0.05. Okay, or the alternative, I could have put 0.28 in here and worked out z. If x is 0.05, then y, we'll put 0.05 into here, y will be 0.23. And if I put 0.23 into here, then z will be 0.27. And then those are your 3 answers. Okay, so information that you've been given, and then information you just need to think about what you know about that union in order to need to form the other equation. If you've got 3 unknowns, you need 3 equations. If you've got 2 unknowns, you need 2 equations, and so on. There are some similar questions from the Year 1 book, exercise 5b, so you can have a go at those and practice that. And that's the end of this second video.